Come back. Problem 4. Volume of the solid obtained by rotating the region bounded by y equals x squared, y equals 2x above the line x equals 2 can be computed using method of washers via an integral. Limits of integration. They can also be computed using cylindrical shell via this integral. These are the limits. Either case, what is the volume? So they want us to set up the problem both using washer. Washer is nothing but a thickened region between two concentric circles, and they want us to use cylindrical shells. So the region is between y equals x squared and y equals 2x. Let's draw the picture. Y equals x squared, y equals 2x above the line x equals 2. Y equals 2x is this line. Y is equals x squared is this curve. It's a parabola. When x is 2, using either one of these, the intersection point is 2, 4. Right? X is 2, y coordinate is 4. So that's your intersection point. So you want to take this region between this line and this curve and rotate it about the line x equals 2. Now here is using a thickened circles, right? There is an outer radius and there is an inner radius. For each, so notice the thickness is delta y because thickness is upside down. So that tells me my integration is going to be with respect to y. For each y from 0 to 4, right, you are going to have thickened concentric circles, thickness delta y. Outer radius, well, the entire distance is 2. I want to take away this distance. So that's x coordinate on this line. So x coordinate here is y over 2. So from 2, I want to take away y over 2. So 2 minus x is 2 minus y over 2. So that's that radius. What about the inner radius? Inner radius is all of 2 minus the x coordinate of the lower curve. X coordinate is square root y. So 2 minus x coordinate of the lower curve, which is 2 minus square root y. So that's your outer radius, that's your inner radius. You have the radius, you know you're going to take integration with respect to y. So dy. So volume is integral 0 to 4, 0 to 4 pi outer radius square minus pi inner radius square. Get the pi out. You have integral 0 to 4. When you open it, you get 4 minus 2y plus y squared by 4. Complete square minus 4 plus 4 square root y minus y. Another complete square. Upon simplification, the 4's go away. You are left with this expression. So this is using washers. So the integral is with respect to y. The limits of integration are 0 to 4. And I am going to take integration of, do not forget the pi. You are multiplying it to something. What? Y squared over 4, y power 2 over 4 minus 3 times y plus 4 sqrt parentheses y. Okay, you notice we can check every time we submit something. Okay, let's check. So that's correct. The first part is correct. Let's continue to the next part. Using cylindrical shells. Okay. By the way, you could continue here and find the volume. Let's set it up the same problem using cylindrical shells. So now I have cylindrical shell of this height. The radius is the same, 2 minus x. Thickness now is delta x. So for each x going from 0 to 2, because thickness is delta x, I'm going to integrate with respect to x. Radius is 2 minus x coordinate, and height is upper height minus lower height, 2x minus x squared. The volume is therefore integral 0 to 2 pi radius height dx. Okay, so now we are using cylindrical shell. So 2 pi radius height dx. Now simplify. Get the 2 pi out, integral 0 to 2. All of this simply multiplying, you get x cubed minus 4x squared plus 4x. So let's write that part first down. So limits of integration are 0 to 2. Lower limit is 0, upper limit is 2. You're taking integration with respect to x. And what goes inside, don't forget 2 pi. 2 pi times parentheses. This is x power 3 minus 4x power 2 plus 4x. Don't forget to close the parenthesis. So let's make sure it's all correct. Fantastic. Now, find the final volume. So while we are here, why not use this? Integral here is x power 4 over 4. Integral here is 4x cubed over 3. Integral here is 4x squared over 2. Limits of integration 0 to 2. 0 fetches me nothing. Substitute 2 and you get, simplify, 8 pi over 3. It's correct. All right. Next problem. It's a similar problem. You have region x equals 3y squared, y equals 1, x equals 0. So region bounded by these three conditions, and you want to rotate it about the y-axis. So let's look for it. X equals 3y squared, y equals 1, x equals 0. X equals 3y squared looks like this. This is the curve x equals 3y squared. Y equals 1 is the horizontal line on the top. Okay, y equals 1 meets this curve at 3, 1. Okay. All right, 3, 1 is the place where this curve and this line meet, because when y is 1, substituting, x gets to be 3. Now, you want to take the region between that curve, y equals 1 and x equals 0. So, the curve, the line, and the y-axis. So, that region you want to rotate about the y-axis. So, if I use Washer's method, that is thick and concentric circle, the thickness is up-down. So, thickness is delta y. So, that tells me I'm going to take integration with respect to y. And for each y going from 0 to 1, width is delta y, radius. What is the radius? Radius of this circle is x coordinate, but x is 3y squared. So the volume is integral 0 to 1 pi radius squared dy. So pi, 3 squared is a 9, y squared is y to the power 4. And if I integrate it, I get y to the power 5 over 5. Limits of integration 0 to 1, 9 pi over 5. So this was an easier one with washers. So let's work with this. So for washers or discs, here is dx. My integrand is 9 pi y to the power 4. So multiplying 9 pi to y to the power 4. Limits of integration are 0 to 1. Okay, and I calculated it here. So 9 pi over 5. All right, so, oh, I'm sorry, it is integral with respect to y. There you go. Of course, so everything is good. Now the next part is using cylindrical shells. So that's the region, and you rotate it about the y-axis. You have cylindrical shell going up, down. In other words, thickness is delta x, which tells us x goes from 0 to 3, right? We come up with thickened cylinders. Radius is x coordinate because you're measuring from y-axis, and the height is 1 minus 3y squared. 1 minus y coordinate, basically. So to find y coordinate, divide both sides by 3 and take square root. So y coordinate is square root x by 3. So the volume here is, let's write this expression down. This one is with respect to x. 2 pi times x, parenthesis, 1 minus square root x divided by 3. Don't forget to close the square root parentheses, and don't forget to close that parenthesis. Limits of integration 0 to 3. Everything is good. We stop here, continue in the next video.